All right, guys, so right here we want to write an equation of the quadratic function represented by this graph. And what's the easiest form to write in? Standard, vertex form or intercept form? Vertex form, okay? So this right here is vertex form. Y equals a parentheses x minus h squared plus k. Looking at this graph, we could identify the h and k value. So here is your vertex, and what is that vertex? 2 and 2. No. 2 and 1, right? Vertex, and the question is, do we know the a value? Now you might be thinking, oh, the a value is -1, but does it really have the pattern of 1, 1, 2, 4? It doesn't, right? It's actually narrower. Okay, so the a value is, we don't know the a value. In order to write a vertex form equation, you need the a value, the h value, and the k value. You need the a, you need the h, and you need the k in order to write your vertex form equation. So what are we going to do? We're going to plug in h, k, x, and y to solve, or into the vertex form to solve for a. Okay, so what we're going to do is plug in h, k, x, and y. So it's obvious that h is right here, k is right here. Where am I going to get an x and a y value from? We're going to get another point from the parabola. So check this out. I'm going to zoom in. Which other point could I use that's a clean point on this parabola? -1, 1? Wait, -1, 1's over here. Or 1, -1, that's a nice point. Or you could even go 3, -1, right? So I could use 1, -1 or 3, -1, whichever one I want. Which one do you guys want to use? 3, -1? So we're going to go 3, -1. We're going to use 3, -1. Let me zoom back out. So what this says is that we need to plug in h, k, x, and y to solve for a. So h is 2, k is 1, x is 3, y is -1. Let's plug it all in. -1 equals a, which we don't know what a is, so we just put a. We have the parentheses, we have the square. Inside the parentheses, you have an x minus h. X happens to be 3. Minus h is -2 because h is 2. And the k value is 1 that you're adding at the very end. Does everybody get that? Okay, now all we have to do is solve. So when I go inside the parentheses, 3 take away 2 is 1. 1 squared plus 1 at the end with the a out in the front equals -1. So what is 1 squared? That's 1 times a plus 1, and it equals -1. So when I go a times 1, that's just a. So I have a plus 1 equals -1. So what does a equal? A equals -2. That's what my a value is. And now that I have my a, now that I have the a value, and I also have an h and a k, because I know my vertex, now I could actually write my answer, which is y equals a, which is -2, parenthesis x minus h, which is -2, close parenthesis, to the second power, plus k, which is +1. Ladies and gentlemen, that's your answer right there. You got it? Got it. Okay. We're going to practice graphing right here. This standard form, quadratic trinomial. The a value is -3. I know it's going to be opening down. I know it's going to be vertically stretched, so it's going to be kind of narrow. But anyways, how do you start graphing a standard form quadratic trinomial? You're going to start by finding the vertex using x equals -b over 2a. And when you use it, please use parentheses before plugging in your values. So the b value is 6. The a value is -3. So when you plug it in, you actually get x equals -6 over -6, which equals 1. Yay? Okay, so the vertex x value is 1. You could write that in as the first part of your answer on vertex. Now, how do you find the y value? you substitute it. Substitute that 1 value inside parentheses in my original graph. So I got my original graph, and instead of x's, I put the parentheses. And now I'm going to plug in the x value of 1 to find my y value. So 1's going to go in here and right there. That's really going to be negative 3 times 1 plus 6 times 1 plus 1. If I do this, I have a negative 3 plus 6 plus 1. What's my final y answer? 4, right? So the vertex is 1, 4. That's my vertex, and you get a point for that, okay? So what do I do from that point? I actually graph it. Let me go to the graph, and let me do 1, 4. I'm going to go 1 on the x, 1, 2, 3, 4 on the y. So it's right here. There's my vertex. Do a big fat dot. You also want to do an axis of symmetry running right through that vertex. Yay? Okay, so I have my vertex. That is the coordinate 1, 4. You could write it if you'd like. There's 1, 4. I need more points, guys. So what I'm going to do is use a pattern. You could use an XY table. If you like the XY table, go for it. And it's actually pretty easy to use if you think about it. You could plug in a number for x, pull out a number for y. What would be an easy number to plug in right here? Even easier. 0 would work great because 0 cancels everything out except for the 1. So you could plug in 0, work it out, get out a 1. So if you'd like, you could actually graph the coordinate 0, 1. And if you do graph the coordinate 0, 1, 0, 1 will be right here, and you could map it to the other side of the axis of symmetry, and you already have the beginning of your parabola. Yay? Now, the other option would be to use your pattern of 1, 1, 2, 4, 3, 9. Okay, I wonder, let me see. So the pattern 1, 1, 2, 4, 3, 9 is right here, and that's the old pattern when your a value is equal to 1. But does this a value equal 1? No, it has an a value of 3. Well, technically negative 3, but we're just going to pretend it's 3. The negative part just says that it opens down. So how do you change the a value of 1 to the a value of 3? You have to multiply by 3. So if you actually were to take your y values and multiply them by 3 on your pattern, you'll get your new pattern. So 1 times 3 is 3. 4 times 3 is 12, and you'd get these new y values. So that would be your new pattern. 3, 12, and 27 for the 1, 2, 3. Does that make sense? Yeah. Okay, so in reality, you'd be going 1 over 3 down. So if I did go 1 over from the vertex 3 down, I'd get to that same point anyway. Okay, so let me do that. Let me zoom in. And I want to go over 1 and 3 down. 1 over 3 down. And the next one would be 2 over and 12 down. So if I did go 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, man, 10, 11, 12, you'd end up at this dot, and you could reflect it over to the other side, which is 2 units away right there, and you have your complete and total parabola done. So we have our parabola graphed. What else did we need to state right here? It's a minimum or maximum? Max, and the axis of symmetry is x equals 1.